is the probability of the data given the hypothesis, and the second one is the probability of the hypothesis given the data. Okay? Now, if you think about these two things here, typically this is what is, I suppose, this is the process in relation to null hypothesis significance testing. Okay, we assume a particular hypothesis, we form some particular hypothesis. Okay, we assume it to be true. We go off and we do an experiment, and then we calculate the probability of observing that particular data under the condition if the hypothesis was actually true. Okay, and I suppose there's a decision rule, and the decision rule is if that probability is very low under the condition that the hypothesis is true, well then it's more than likely that the hypothesis is actually false, if that makes sense. Okay, well, that's the process of null hypothesis significance testing. Okay, we start off with a hypothesis, we do an experiment, we collect our data, and then we calculate the probability of observing that data under the situation of where the hypothesis is assumed to be true. Now, that's not really the way it works in the real world. In the real world, you walk around the real world. Okay, you walk around the real world every day, observing data. Okay, every day you observe data every day as you walk around the real world. Okay, and then after you walk around the real world for a little bit of time, okay, you form beliefs. Okay, beliefs. Okay, with respect to the real world. Okay, you form hypotheses. Okay, hypotheses, and you assign probabilities to them, and that's what this is here. So this probability here is, okay, we know the data is real within measurement error. Okay, because we've observed it. Okay, so that's true. Now the question is, okay, after observing that data, I've formed some sort of opinion in relation to the real world, some hypothesis in relation to the real world, and now the question is, what's the probability that my hypothesis is true, given that I've actually observed this particular data? Okay, and this is the Bayesian. This is the Bayesian way of doing things. Okay, and what Bayes' theorem allows us to do is allows us to calculate this probability. Okay, allows us to calculate this probability based off, I suppose, let's say, prior knowledge. Okay, this thing here on this side, so we're looking on this side, the probability of D given H is known as the likelihood. Okay, so this is known as our likelihood probability. Okay, so we have, this is our likelihood. Okay, it's the likelihood of the data given the hypothesis. Okay, the probability of H, okay, and the probability of D, okay, these are, I suppose, these are called the marginal, okay, this is called the marginal probability, okay, and also it's called, I suppose, let's say the marginal and the prior probability, okay, if that makes sense. Okay, so what we have is, we have, in this case, so we have the marginal and the prior probability. So we have our marginals and we have our priors. Okay, the prior probability of the data, the prior probability as well of the hypothesis, if that makes sense. Okay, so let's just try to keep that particular thing in mind here. Actually, I suppose the probability of the data is really called the marginal. It's the marginal probability, yeah. Okay, where this is the conditional probability here of the data. So it's the marginal likelihood, and this thing here is called the prior. Okay. And then this thing here is calculated, okay, after we've estimated, or after we've come to a decision in relation to them particular probabilities. Okay, so this here is called the posterior likelihood, or the posterior probability. Okay, so this is the posterior, let's say, likelihood, okay, or probability, okay, if that makes sense. Okay, so, well, that's Bayes' theorem, hopefully in a nutshell. The next couple of videos are going to explore, I suppose, applications of Bayes' theorem. There's some classic examples. We'll probably have a look at one or two. One in relation to maybe where a physician has to make a decision, where patients are coming to the physician with spots, and the physician needs to figure out whether the patient has chicken pox or whether the patient has smallpox. That's a classic sort of example. Another thing is where we'd like to figure out whether, in relation to email, whether an email is a spam email or it's not a spam email, if that makes sense. Let's say spam filtering, and I'll have a look at some examples in relation to that. So guys, once again, I hope that this demystified in some way this concept of Bayes' theorem and what it's all about. As I said, the starting point of constructing Bayes' theorem is simply the multiplication rule. When we assume the events are dependent on each other, we just equate them together and we get this rule which allows us to flip the conditionals, okay, effectively. Yeah. Okay? When we take it into the perspective of where the events represent hypotheses and they represent data, I think it becomes a little bit more accessible in relation to what's happening in the real world. Okay, this Bayesian statistics, this probability of the hypothesis being true, given we observe the data, is something that's a little bit more natural. Okay. But once again, guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And I hope this video was intuitive, and more importantly, I hope that was helpful for you, and thank you for watching. Okay, bye bye.